Hi everyone. Today I'm going to talk about my project, which is the machine learning for mental health risk prediction. So I'm a part of a team 18, and our team members consist of me, myself, Abhijith, Abhishek, and Prasanna. So, starting with the overview of the project, the objective of this study is to develop a machine learning system that accurately predicts mental health risk levels by analyzing behavior patterns, so work environment factors, and lifestyle indicators. So, moving down to the methodology, our approach combines three complementary datasets, which are the employee mental health dataset, which captures the work environment impacts, then general mental health dataset with the comprehensive risk indicators, and lifestyle mental health dataset with the sleep and social patterns. So the data integration involved standardizing formats, handling missing values, and aligning categorical variables. And the machine learning techniques are divided into three and is assigned to the team members. For me, myself, I chose the neural network. The neural network is a powerful machine learning algorithm which is similar to human brain structure. And let's move down to the demonstration part now. So first of all, we will start off by importing the necessary libraries. So these are the important libraries we used. And then we will move down to loading and exploring the data sets. The DF1, DF2, and DF3 are the data sets we used. So we will first print off the data set, then we will print the first 5 rows of the data set, display the information of the data sets, and this function will check whether if there's any missing value, and this one will describe the type of the data. So these are the first 5 rows, and this is the shape, and then this is the information about the data set, and these are the missing values if there's any, and this is the description of the type of the data, and we can see the missing. So in the next step, we are doing the data cleaning and pre-processing. So first of all, we have to define a function to check the missing values. If there's any missing value, we have to calculate the percentage of the missing value. And if there is no missing values, we have to print out there is no missing value. We have to check the missing value in each data set. Then we have to define a function to handle outliers. And then we have to define a function to encode categorical variables, which means in order to train our machine learning models, we have to convert these text columns into something numerical. For that, we will use the label encoder. What it does is which will assign a unique value to each category. Once it's done, it gets stored as a df1 encoded, a df2 encoded, and df3 encoded. So as a output, we can see we will check the missing value, and we will check the percentage of the missing value. The next step, we are doing the dataset integration and feature engineering. So we will identify the common features across datasets. And for that, we will define a function, get common features, and then store all those common features in this dictionary. And then we will create a function to create a unified dataset. And then we will combine all these, and we will make a combined missing values. Like we didn't done before, we have to check if there's any missing value in this data set as well, this combined data set. So if there is any missing value, we have to handle it because it will create trouble while training the model. So for handling the missing value, we have to fill the categorical columns with mode, and fill the numerical columns with median. Once after everything is done, there is no missing value in the unified data set. We are doing the feature engineering. So firstly, we will create new features that might be relevant for mental health analysis, such as overall wellness score, or work-life balance index, digital lifestyle impact, age groups for easier analysis, and stress sleep ratio. Then we'll combine the social score, and then combine the normalize the social scores, work-life balance category, and display the dataset with new features, and save the cleaned unified dataset. Once it's saved, or once we run it, the new cleaned dataset will be displayed here. I have run it before, that's why it's showing here. Which will only show the statistics for numeric columns to avoid with the categorical columns, and then we'll create the correlation matrix for numerical values, display the top correlations with the stress level and mental health. And we will plot the correlation heat map, visualize key relationship, age versus such as age versus stress level, gender versus mental health, and etc. This is the things we will be doing in this. This is the correlation matrix of mental health factors. This is stress level distribution by age group, average mental health condition by gender, and yeah, a relationship between work hours and stress hours. Yeah. You're preparing the data for machine learning. Let's now just dive into the neural network model. So yeah, this cell practically evaluates neural networks to predict whether the person's stress level is based on the features that we basically kept in our data set. The start time loads a time, and this function train neural network basically builds neural networks and evaluates performance. First of all, the architecture, there's like two layers, three layers: input layers, hidden layers, and output layers. The top port is set to prevent overfitting. And okay, and we'll train the model, and we'll calculate the training time and evaluate the model on the test data, and calculate the performance by the upload actual versus predicted values, upload error distribution, and then we will train and evaluate the neural network model. So these services. So we can see the lows, and we can see the mean absolute error and the predicted stress level. This is actually good. And yeah, we can see now the neural network model training and evaluation is completed. So what I left here, it's like to calculate the performance the metrics, the mean squared errors is like the actual performance minus the performance, and it is a square root of a mean squared error, and yeah, that's basically all of it. Now let's dive into the conclusion part, which is the comparison between all the three models. The final part, which is the comparison part. So this cell actually compares all the three models, and we can see that among the three models, the random forest model has the higher accuracy rate. So that's the end of my presentation. Thank you so much.